On 27 January, DeepSeek became the most downloaded app in the world. It overtook GPT, Gemini, Claude. It started to overstate how the big deal is. I mean, OpenAI, a company that invested over $100 million, could have built DeepSeek 16 times with that budget. And we all know ChatGPT. You might even using right now to find answers, explanation, and solutions. So what on earth did DeepSeek do? A. Manage to build their AI with limited resources, and B. Actually overtake the biggest AI companies. One thing I want to make super clear, which makes this almost surprising, is that DeepSeek AI only started in 2023, established as a subsidiary of Firefly, the quantitative hedge fund co-founded by Liang Feng in 2015. And you have probably seen this face all over the internet, but here's the truth, that's not him. A lot of fake images are floating around, but this is the real Liang Feng. Liang was born in 1985 in Yunchuan City, China. He started at the Zhejiang University, earning a Bachelor of Engineering in Electronic Information in 2007 and a Master of Engineering in Information and Communication in 2010, where his career in AI began. After graduating, Liang moved into a cheap flat Chengdu, Sichuan, where he experimented with applying AI to various fields. These ventures failed until he tried applying AI to finance. In 2019, Liang founded Firefly AI, dedicated to researching AI algorithms and their core application. By this time, Firefly managed over 10 billion yuan, which is approximately $1.4 billion assets. By 2021, Liang started buying thousands of NVIDIA GPU for his AI side project. Before the US federal government imposed AI chip restriction on China, where in 2023, Liang founded the DeepSeek company. But what actually makes DeepSeek AI so powerful despite it being built on limited GPUs? Okay, quick lesson. AI works by analyzing data. It trains pattern and make prediction or decision as it's trained using massive datasets and powerful computing systems through a process called machine learning. So imagine you are training a robot chef to cook the perfect burger. Here how it works. Step 1. Learning from ingredients and recipes. Before the robot can start to cook, it needs a ton of data, thousands of burger recipes and millions of food images. It studies the ingredients, cooking method, and what makes a burger perfect. Just like that, AI learns by analyzing massive datasets before making decisions. Step 2. Learning pattern and mistake. Now the robot started making burger. At first, it might burn the patty, add too much sauce or forget the ingredients, but it learned by comparing its burger to the best one, so adjusting as it goes. AI does the same, tweaking its predictions through training. And this is why training process take a lot of time. Step 3. Getting better with the experience. With the time the robot improves, it remembers which ingredients make the burger juicier and avoid the past mistake. Just like AI, which refines its model over millions of cycles to becoming even more accurate. Step 4. Mastering the perfect burger. After extensive training, the robot can now make the perfect burger, customized to different tastes, like it was a full-trained AI, which can generate text, recognize image, or make spot-on recommendations. But here the catchy. Training AI isn't a simple task. It requires processing massive amount of data, performing millions of calculations, and fine-tuning complex models. And that's where high-performance GPU even come in. Unlike CPU which processes tasks one at a time, GPU have thousands of small cores, allowing AI to learn faster and smarter. They handle huge matrix operation essential for deep learning. But DeepSeek faced major challenge. In response to US export restriction on vast AI chip, the company had to adapt. Instead of relying on cutting-edge model like NVIDIA H100, they turned them to H800 GPU, one of the fewer options legally available in China in 2023. This GPU comes with trade-off. The H800 has reduced performance compared to the most advanced AI chip, but DeepSeek didn't let that hold them back. Instead, they engineered their training process, optimizing efficiency and reducing the compute state of processing input and output knowledge using a single large model. DeepSeek divided its AI into smaller specialized models called aspects. Each aspect focused on unique tasks, whether it's domain, language syntax, or another specialization. So DeepSeek saw that coming fast and came up with new idea. Here where it gets smart. Instead of passing every input through all aspects, which would waste resources, DeepSeek uses a router network. This router decides which aspect should process the input, whether it's the first or last or specified one. And this approach saves computation power by ignoring unused aspects, keeping them free from other tasks. As DeepSeek improved its MO system, it increased the number of experts while also introducing shared experts that learn general knowledge across different contexts. This left the space for other experts to focus on learning deeper and more specialized knowledge. And this is why DeepSeek learned efficiently on limited GPU, by only activating the right expert at the right time, rather than wasting the resources on unnecessary calculations. And this is what caused DeepSeek to fly so high.